So we're now on video part 2. So I just wanted to review what we talked about in part 1. We went through sections 2.1 to 2.3. So here I'm going to finish up 2.4 and 2.5, transformations of functions and quadratic functions. All still pretty much review. And again, please remember that you end up having many things that are tested from this section on the IB exam. Your formulas again. And reminder that on page 74 that homework is mandatory. Everything else, numbers 1 through 5, are optional unless you do poorly on the test. So to start off in section 2.4, we're talking about transformations of functions, so you have to know some basic functions. These to me are not all the ones that you need to know, but we will review the other graphs. These are the basic functions that they express that you should know prior to the chapters in the text. So sine function, cosine function, the log function, the exponential functions, those will come later. So given here, the only thing that I thought was interesting was the fact that you should know the name reciprocal function, which is 1 over x, and then you should also know the inverse square function. The names, you want to make sure that you understand terminology in case instead of giving you the function, they actually use the wording. Notice that this here is an odd function, symmetric about the origin. Turn it upside down and it'll still look the same. And this here is an even function, symmetric about the y-axis. Just things I wanted to mention. All right, so rules for transformations of functions. So I'm going to actually write y equals plus or minus an a value outside of a function plus or minus b x minus, and I'm going to use, I guess, h, and then plus k. And the reason I'm using h and k is because I believe that's what your book uses. So I'm actually going to just summarize all the transformations that you essentially need to know based off of what's here. So if you have a negative value on the outside of your function, you will be reflecting across the x-axis. If you have a value multiplied outside of the function, the a, if a is greater than 1, it's a vertical stretch. If a is between 0 and 1, it's a vertical shrink. And the last vertical transformation is in the back here, where if it's a positive k value, if k is greater than 0, it's moving up k units. And then if k is less than 0, if it's negative, then we're moving down k units. Up top, which I'll use orange. If I have a negative inside of the function, you're reflecting across y-axis. If I have a b value inside, and here's where it gets a little tricky. We're going to start talking about opposites. So if b is greater than 1, we do the opposite. Instead of thinking about it as a stretch, it becomes a shrink horizontally. If b is between 0 and 1, you horizontally stretch. Numbers that are between 0 and 1 tend to be values you would think would cause a shrink, but inside of the function, any transformation that occurs would cause you to have horizontal transformations, and all horizontal transformations are opposite. Now, one thing I just realized is that that parenthesis should be there and not here, so sorry about that. Hate making mistakes on these videos. All right, so inside the function now is a little bit more clear. I'm going to highlight the part that would be considered inside the function in green. So all of this is considered inside the function. What I mean by that, the transformations happen on x, which mean that they're all horizontal. So I have one more to do, which is over here. If h is greater than 0, you're moving left h units. And if h is less than 0, if h is negative, you actually move right. So again, opposite. So quick example. would be given a function, square root of x, the transformations that happen to get g of x, given -4 the square root of -x minus 3 plus 2. Some major things to consider. You want to make sure that the inside is factored so it looks like the standard form. So I want to factor out the negative value, which will cause this to be x plus 3 and then plus 2. So we're going to actually highlight each transformation in order, just from the front to the back. So the negative here would be a reflection across the x-axis. Since we're outside, all the outside transformations I'll do underneath in red. So the 4 on the outside would be a vertical stretch. It takes the y values and multiplies them all by 4. In the back here, it takes all the y values and moves the function up 2 units. And then we're going to go back and pick up these x value or x transformations, and how I'm going to do that. Hopefully, that is not what I meant to do. Hopefully, I'm going to be able to move this. And let's see. Oh, it wants to move it all. So, alright, so I won't be able to move it. I am just going to erase. And put the g of x right here. So, on top, in orange, I would have left over this transformation here, which would be a reflection across the y-axis. This here would make me move to the left 3. So inside of the square root are the transformations that happen on x. It's interesting that I say transformations happening on x, but we're reflecting across the y-axis. If you think about it, take an x value and make it negative. So take a point, 2, 3, and make the x value negative. Where does the point go? It goes from being on the right side to the left side. It reflects across the y-axis. Moving on, write the equation of the absolute value function whose graph is shown on the left. So you want to make sure that you can write absolute value function equations. Absolute values are usually pretty easy. The basic thing is first figuring out where your vertex is. Let's see, y is equal to. So I want to know if the value in front will be positive or negative, and in this case the absolute value function is facing upwards, and so this is a positive absolute value function. The vertex has shifted, so I'm going to put x minus -2 and then plus -3. So the way that function notation works, inside of the x, or with the x, is always a minus, and outside is a plus. So what this actually ends up looking like should look a little more familiar. This is a transformation to the left 2. This is a transformation down 3. And then the last thing that we have to check is the slope value. So from here to here, I would be rising 1, 2, 3, running 1, 2, 3. So the slope of this function is 1. Okay? So for g of x is equal to 2x cubed minus 6x squared plus 3, find the function h of x that is a reflection of g in the x-axis. So I want to take g, and I want to reflect it across the x-axis, which means that I would want to have my y values be negative. So this is negative f of x. Doing a reflection across the y-axis is f of negative x. So how do you use that notation inside? What we would do is take our g of x and we would write it in notation. So if I want to reflect across the x-axis, I would take g of x and do negative g of x. And part b, I would want to do g of negative x. And once it's in that notation, it should be a little easier to understand what they're asking you to do. So in this case, I would put negative 2x cubed minus 6x squared plus 3 and distribute the negative. Whereas in this problem down here, I would put the negative x as the input of my function. And then I would simplify. In this case, this one I will simplify for you. The negative does not simplify for the cubed, but for the x squared, it will simplify because a negative squared is going to still be positive. So the summary of your transformations is given a little bit more detail in the back of the section. I went through each of them kind of all together just because I know you've gone through these transformations before. So just to clarify, you'll notice what I mean by inside the function. So this is inside with x, inside with x, inside with x, inside with x. The only difference is when I was giving you your rule, I think I used the letter b for this one. I actually did f of b x. The only difference. So this one was in your textbook, and I just wanted to show you the answers to talk about the different transformations, because that way you actually know what they're doing. So looking at the original and looking at the actual function, what happens is if you take the original function and pick a point, so I'm going to pick the point 1, 1, and we're going to use 1, 1 throughout. Actually, let's use 3, 1. I think I like the fact that it's not 3, -1. They're not going to be the same value. 3, -1. So if you look at letter A, this transformation is a vertical stretch by 3. The point 3, -1, you'll physically take the y value and multiply it by 3. So you should notice that if you go to 3, the y value is now -3. If you look at part for that whole entire function, it takes all the y values and multiplies them by 3, which causes it to look like a vertical stretch. Part B says take my y value and then multiply my y value by 1/3, and we get this, which would take all my y values and make them very small, causing the function to vertically shrink. Letter C, this is the confusing part. So f of 3x, what it's actually going to do, it takes the point 3, -1, so it takes your x value and divides by 3 instead of multiplying, because it's the opposite. So it does a horizontal shrink. So what you'll notice is the point 1, -1 was actually 3, -1 originally. And then letter D, the 1/3, takes the point 3, -1 and takes the x value and divides it, multiplies it by 3 this time, so I get 9, -1. And what you'll notice is it's all the way out here, causing it to vertically stretch. All right, last section, quadratic functions. So a quadratic function is written as ax squared plus bx plus c, where b and c can be 0, but a cannot. If you make a equal to 0, you end up with a linear function. The name of the shape is called a parabola. You know that parabolas open upward or downward. Please make sure you notice that the vertex is where the axis of symmetry will cut straight through your parabola and cause it to have symmetry from right to left. Vertex form of quadratic function. So the vertex form is very nice and easy. Given that you know the equation, which I'm rewriting here, it tells you that you can always figure out the vertex. The vertex was always going to be h, k. And then the other thing that's nice, the a value, if a is positive, it opens up. Negative a opens down. Completing the square. So completing the square is a skill used to create vertex form from standard form. So what you see here is standard form. So we're going to review completing the square, but then I'm going to show you a way to cheat and not actually have to complete the square. We'll end up doing it to the same problem. So completing the square essentially says, take your function, set it equal to y, so it makes it a little easier to look at. It's the only reason. You're going to move your constant over so that you have only your x variables to the right side. You are going to double check that my coefficient of x squared, right here, equals +1. If it's not, you need to move that over too. Either that, we're going to have to factor it out. Otherwise, you're going to take this value, which is -8, you're going to divide it by 2, and then you're going to square it. What you end up with is x minus 18 is equal to, and watch what I do, I'm going to factor it all in the same step. Oh, no, I'm not. Not yet. I should not do that. I'm not going to skip the step. I'm going to move over to the right side here. And I'm going to make sure that I have y minus 18 is equal to x squared minus 8x. And what I'm going to do is take that value that I got right here, which is negative 4 squared, 16, and I'm going to add 16 to both sides of my equation to keep it equal. I'm going to simplify the left side, which I get y minus 2. I'm going to simplify the right side by factoring, and completing the square works out the same way every single time. It's going to be a perfect square. So if I take the 16, two numbers that multiply to positive 16 but add up to negative 8, you'll get negative 4, which is the exact value inside of these parentheses every single time. So there is your vertex form. Final answer would be that y is equal to x minus 4 squared plus 2, where your vertex is 4, 2. So that is completing the square in a very quick and dirty way. I'm going to take the exact same problem and show you that you can get away with not having to complete the square for this section at least, and we'll see if we need to learn the real way later. So, given this skill, completing the square, for this type of problem, you actually can get away not having to do it if you find the vertex. So x is equal to negative b over 2a. So in this problem, negative b over 2a gives me the value of 4. The y value of my vertex would be 4 squared minus 8 times 4 plus 18, which will hopefully give you the same value that we had before, which was 2. Which should make sense. 16 minus 32 would give me negative 16 plus 18, which should give me positive 2. So I get that my vertex is 4, 2. And I need my a value, which is 1. That is pretty much all you need to write your vertex form of your equation, which should match the answer we had a minute ago. So that's a nice little shortcut for completing the square, which only works for parabolas. All right, so for the function given in map notation, find the vertex and the axis of symmetry. So axis of symmetry formula is given for you, negative b over 2a. You want to just make sure that when b is negative that you put the negative over 2 times negative 2. So we get 12 over negative 4, which is negative 3. So there's my x value. So x equal to 3 is my axis of symmetry. Or sorry, negative 3. X equal to negative 3. The y value, I would take negative 2 times negative 3 squared minus 12 times negative 3 plus 7, and that will give me negative 18 plus 36 plus 7, so that should give me 18 plus 7, hopefully, which is 25. My vertex then becomes, if I didn't make any mistakes, there's always a chance that I did, negative 3, 25. B says, indicate the transformations that can be applied to x squared to obtain the graph. So that is really what they're asking you to do is complete the square. I showed you the shortcut, so we already know the answer, but I am going to complete the square for this problem. Given the problem, which I'm going to steal over to the next page. So I can finish the problem. All right, make that a little bit smaller. All right, so given what we got a second ago, which is this, I can cheat and give you at least the answer to part B, but then we are going to complete the square. So part B, the answer would be y is equal to negative 2 x plus 3 squared plus 25. So we'll see if I did that right originally, because I am going to complete the square now. So part B, completing the square, is what they're actually asking you to do to figure out your transformations. Completing the square puts it in vertex form. From there, you can actually write the transformations. So here we go. Y equals negative 2x squared minus 12x plus 7. First thing, move my constant over. Y minus 7 equals negative 2x squared minus 12x. And here's what I meant about the coefficient not equaling 1. I have that coefficient of negative 2. So what I'm going to do is factor out negative 2 and put x squared minus plus 6x. Then from there, and watch, I'm going to put a little bit extra space right here because I'm going to add a number. All right. Let me make this look a little bit neater. All right, so from there, I am going to take my 6, divide it by 2, and then square it. That value that I just got is the number that I'm going to add in here. So that is 3 squared, which makes 9. Problem is, on this side, I'm really not adding 9. I'm adding -2 times 9. That 9 is hiding inside the set of parentheses. So I actually end up with y minus 1825 is equal to, and on the right side, let's use pink, -2, parentheses, remember factoring, you can literally take the value that's inside the parentheses, and that's the value that will always be sitting here. Otherwise, you can factor the trinomial. But let's see what we end up with. -2 times x plus 3 squared plus 25, which I believe matches the answer I had a second ago. So there are the two methods for writing, or at least getting it into vertex form, therefore being able to write out my transformations. So part B, transformations would be, and I'm going to write them here because I have more space, reflect across the y-axis, sorry, x-axis, just kidding. Vertical stretch by 2, left 3, up 25. And then find the minimum or maximum value. So minimum and maximum value, you really don't need to get to the point of having to use calculus. You just need to understand this is a parabola where a is -2. What that tells me, it's facing down. Remember, the vertex was going to be -3 comma positive 25. So there is a maximum at -3 comma 25. The value of the maximum is positive 25. Make sure you understand that that's the value. The location is -3. Symmetry and vertex. So you saw me kind of use the formula already. X equals -b over 2a. And the vertex has coordinates. I don't ever memorize this second part because I think the y value of the coordinate, you just substitute the x back in. So there's no need for a formula. The next part just shows you ways to solve. So I listed it, but really the methods that you should really get to know, you should already know how to just use the square root principle, which is pretty rare for you to be able to do. Factoring, extremely important, and quadratic formula, I would say. Quadratic formula works anytime you're trying to solve a quadratic where it's not factorable or it takes too long to factor. For the quadratic formula, this delta stands for discriminant, and the discriminant is the part that's underneath the square root. So if the part underneath your square root is positive, then you'll have two distinct roots, meaning the parabola will intersect the x-axis twice. If it's equal to 0, it'll be tangent to the x-axis, meaning it'll only hit and bounce off. And then if it's negative, the parabola will never hit the x-axis, meaning it'll float above or below. Use a discriminant to decipher, I guess, how many real solutions that you have. We'll just do part A, b squared minus 4ac. That's what you're looking at. So you have 3 squared minus 4ac. So I get 9 plus 4, which is greater than 0, therefore 2 real roots. Okay. Example 27, determine the value of k so that the equation has 1 real root. So we'll do, I guess, we'll do 1 real root, just letter A. So I know that b squared minus 4ac would have to equal 0. That's a discriminant. So b squared, which is 4k minus 4ac equals 0. So we get 16k squared minus 144 is equal to 0. So we get k squared is equal to 144 divided by 16. So k squared equals 9. So k is equal to plus or minus 3. So in this case, there are two values. And then from there, what I would essentially do is I would put the value of k back in, And then I would do sign lines to check if the b squared minus 4ac is positive or negative. If it's negative, you'll get the no real roots, and then if it's positive, you'll get the two distinct. Factorized form of a quadratic function, that's your way of knowing intercept form. So when there's two intercepts, there's two factors, and so you'll notice if you write the two factors and just put your a value in front, that's the factorized form. And I believe that's everything. Pretty awesome. All right, so there's your part 2 video, which I'll put up today, so a day early for you.